Today we're going to find the derivative using implicit differentiation. So what we've done so far is find the derivative using explicit differentiation. That's when we were able to solve the equation for y. Now our equations, we're not going to be able to solve them for y, or they're going to be very messy if we do. So what we do, so when you have an equation that's not y equals, we're going to use implicit differentiation. That means we just take the derivative like normal, okay? But every time we take the derivative of something with a y, we're going to put a dy dx with it. That just means we're taking the derivative in terms of x. So here I'm going to go term by term and just use my power rule. So this will be 6x squared. This will be plus 6y, but since this term had a y with it and I took the derivative, I'm going to put a dy dx with it. And then the derivative of 1 is just 0. Now what we do is solve for dy dx. So I'm going to subtract the 6x squared first. And then I will divide by 6y, and I'll get dy dx equals, I can reduce the negative 6 over 6. That'll just give me negative 1x squared over y. So once you've solved for dy dx, then you're done with the derivative. Now let's look at another one with multiple y's. So again, we're just going to go term by term and take the derivative. So the derivative of x squared is 2x. The derivative of y squared would be 2y. But anytime I take the derivative of a y, I'm going to put a dy dx with it. The derivative of x is just 1. The derivative of y is also just 1. But then we need to tack on a dy dx. Okay. Now, since we have multiple dy dx's, okay, we need to move everything with a dy dx to one side. Okay. I'm going to move it all to the right to keep the dy dx's positive, but if you move it all to the left, that's fine. So I'm going to leave the 2x, and I'm going to subtract this 1. I'm going to add the 2y over. And then the point of moving all the dy dx's to one side is so that you can GCF out the dy dx. You're left with a 2y plus 1. And then your last step would just be to divide by the 2y plus 1. So our final answer will be dy dx equals 2x minus 1 over 2y plus 1. And you can't simplify this because this is stuck together. The 2x minus 1 is stuck together, the 2y minus 1 is stuck together. The only way we would be able to simplify is if every single term had a GCF we could reduce by. Now let's look at another one. So this time we have some trig functions. So the derivative of cosine is negative sine. So that'll be negative 2 sine of x. The derivative of sine is cosine. So that'll be cosine of y, but this term had a y with it. So since I took the derivative, I'm going to tack on a dy dx equals the derivative of x squared is just 2x. So then I'm going to move the sine term over. Okay, you always want to get the dy dx terms on one side, everything else on the other side. So that'll give me 2x plus 2 sine of x. And then my last step is just to divide by what's with the dy dx. So dy dx is going to equal 2x plus 2 sine of x over negative 3 cosine of y. Okay. Now you could GCF a 2 out of this, but since it won't reduce with the 3, I am just going to leave it like this. Okay, let's look at one more. So we're again going to just go term by term. So the derivative of y squared is 2y. And I took the derivative of something with a y, so I need to tack on a dy dx. The derivative of secant is secant times tangent. The derivative of tangent is secant squared, and since this one has a y, I need to tack on a dy dx. And then the derivative of x squared is just 2x. So again, I have multiple dy dx's, so I need to move these to the same side. So I'm going to subtract the secant squared, and that'll put all my dy dx's on one side, and then I'm going to move the secant of x, tangent of x, over. And then once you've done that, okay, now that everything over here has a dy dx, we can GCF that out. That'll just leave us with a 2y minus the secant squared of y. And then our very last step is just to always divide by what's with the dy dx. So our final answer solved for dy dx will be 2x minus secant of x, tangent of x, over 2y minus secant squared of y.